Namaskar, my dear friends. Let us talk about how we can design and simulate non-inverting amplifier in NI Multisim. So there are a lot of circuit design, like softwares, and what we can do is we can try to design non-inverting amplifier in Multisim and simulate it. So as you already know that this is the configuration for non-inverting amplifier. So this positive terminal is like non-inverting terminal, and this is inverting terminal. And let us say this is my input voltage that is going to be here. So the output voltage will be what? The output voltage will be nothing but my 1 plus V out will be nothing but 1 plus R2 by R1 into V in. So this R1 and R2 is actually used to set the gain for this non-inverting amplifier. So let us say my R2 by R1 is 1. So what will be the gain? 1 plus 1, that is 2. So the total gain will be 2. And if my input voltage is 1 volt, my output voltage will be how much? 2 times, that is gain times input voltage, that is 2 volt. So let us take an example. This is the simulated circuit that is there from the NI Multisim. Okay. So we have a input pulse of 0 to 1 volt. Okay. So 0 to 1 volt, you can see we have the red signal 0 to 1 volt, a square wave pulse. Okay. Like zero point 0.5 millisecond on time and 1 millisecond period. So that is half of the period is, this is 50% duty cycle. Now the gain is set here is how much? You can see R2 by R1 is going to be 3 by 1, that is 3. So the total gain will be how much? 1 plus 3, that is 4. Okay. So 1 plus 3, that is 4. It means my V output will be equal to 4 times V input. Okay. So you can see we have 1 volt input, so output is 4 volt. So this is how the pulse is changing, and 0 will be 0 only. So let us quickly see this particular circuit design in Multisim. So let us open this Multisim. We have this particular circuit, and if you want, what you can do is you can take a screenshot of this and try to redesign this particular circuit on your own. So this is my input voltage, this is the resistor setting for the like gain, and this is my output voltage V out. So if you want, you can rename the nets as per your need. Okay. So what we will do is we will take a new circuit and we'll try to design this and show it to you. So what you can do is come back to this new, or you can press Ctrl N or go to File, New. So there will be a new blank circuit that will open. So you just press create and new circuit has been created. Now what do we need is we need to go to place, then components, and put all the things that is needed. So we need one, like let us say we need ground. So one ground is here, one more ground, let us say here, and one more ground is here. So 3 ground will be required. Okay. Then we need, let us say pulse. So pulse voltage source, go to signal voltage source, we need pulse voltage. Okay. So this pulse voltage is there for my input. Come back to basics. Basics is here, and then we have to put resistors. So let us say we need resistors. So resistor one will be like at the negative terminal, then one will be feedback resistor, and one will be, let us say we will put load resistor. Okay. Then we need like a opamp. So for that, go to analog, opamp is there. You can press this opamp. So here there are two opamps, so A and B, because two in one package two opamps are there, so we'll take one of them. Okay. So we have taken one of them. I'll put cancel so that I don't want to put another one. Now we need power supply for opamp as well. If you want, you can use power supply separately, or otherwise what you can do is come back to sources, then power sources, and let us say we'll put VCC. So VCC will be positive supply and VEE will be negative supply. That's all. So plus minus 5 volt you can give. Okay. So this is how my circuit is almost complete. What we can do is we can quickly wire this up. To wire this up, what do you need to do? You need to go here and then quickly wire up. So I'll just put this one here so that it becomes little easy. And then this is my negative terminal, this is my output, and this is my negative power supply, and this is my positive power supply, and this is the input voltage that is going to be. Okay. and this is my load resistor. Okay, so load resistor is connected like this. So my circuit is complete. Load resistor, I'll just increase the value so that the current consumption will be lesser. Okay, so the current will be less. Understood? Now, if you want, you can rename the nets as well, not a problem. So let us say this one I will rename it. So select the net, right click it, properties, and let us say I'll put it V in, so that you know that okay, this is my V in net. Okay. Then similar to that, this one I'll name it as V out. So right click, properties, put it as V out. So this is the good method, proper method to design your circuits, something like this. Okay. What else we need? We need to have probes. So what is the gain here? You can see R2 by R1, that is 1. It means 1 plus 1 2. So gain is 2. So whatever input voltage is there, it will become twice of that. Okay. So if you run it, you will see. Directly we don't need to run. What we can do is we can put a voltage probe here at the input side PR1 and voltage probe here at the output side PR2, and go to simulate, analyze and simulation, put it in transient mode and run it for, this is running for 1 millisecond, I'll run it for 5 millisecond. Okay, so that at least 5 pulses will come, because it is one like a kilohertz it is, right? Now if I run it, what is going to happen? You can see we have input voltage as 1 volt and output voltage is 2 volt, because it is double of that. Since the like graph is not visible properly, so what we can do is we can like increase the trace width or something. So go to trace and trace width, and then similar to that, this trace width to little higher values. Okay, let us say 4. Alright, so my PR1 is nothing but your input voltage, which is 1 volt, and PR2 is output voltage, which is 2 volt. So plus minus 1 volt is red signal and plus minus 2 volt is green signal. Similar to that, if I want, I can change the like gain to, let us say, 3 kilo ohm. So what will happen? The output will be 3 plus 1 4. So 4 times it will be 4 volt up, 4 volt down. So let us run it. So you can see 4 volt high and 4 volt low it is there, and input signal is 1 volt up, 1 volt down. Instead of having the pulse signal, what you can do is you can change this like voltage labels to, let us say, 0 onwards. So 0 to 1 or 1 point, let us say 0 to 1 point, let us say 3. 0 to 3 volt up and down it is. Okay, so what will happen? 3 chauka 12, like 1.2 volt will be output maximum, right? So you can see 0.3 volt is high from 0 onwards and 1.2 volt is upper one. Okay. So this is how the complete circuit design for your inverting and non-inverting amplifier was there. If you want, you can do more things. Let us say I want to play some like text, so I can write it down here. Non-inverting amplifier. If you want, you can change the color of this. So let us say color is this. Similar to that, if I want to put some more text, let us say here it is my input signal. Let us say color, I'll put it some pink color, and this one will be, let us say, output signal. Okay. All right, so this is my output signal. So this is how you have made your circuit very nicely, and all the parameters are like visible. And if you want to increase and decrease the size, you can use your mouse wheel to increase or reduce, or you can use like a what is that? Let us say we have increasing this size or something, zoom in, zoom out. So zoom in, zoom out will be here. Zoom in, zoom out. So everything you can do. So if you do have any questions or any understanding that is needed, you can put down your questions in the comment box and we shall be able to answer you out. And quickly, what I will do is I will change the source to, let's say, some DC signal and show it to you very quickly. So place component. My source is, let us say, DC power. So DC power, I will put it like this DC power is there like this, right? And let us say make this as 1 volt. So what will be the output? Output will be 4 volt because it is 4 gain is there, right? So if you run it, the DC signal input voltage is 1 volt, the output voltage is 4 volt. So I hope I have made you very clear about how to design this non-inverting amplifier and see various outputs for different kinds of inputs. Thank you.